Hello, my dear students. This is our first presentation of physics for class 9th. So, these are the contents of chapter Force and Laws of Motion. So, force. Force is a physical quantity which causes a motion in a body or which opposes the motion of a body or which changes the direction of motion of a body. In our day-to-day life, experience tells us that a body at rest unless someone pulls it or pushes it. In other words, some push or pull, that's an external agent, is needed to set a body in motion from its rest position. For example, if a body is moving over a surface, then again some push or pull is needed to stop the motion of the body. For example, when we put our hand in the path of a moving ball on the surface or floor to bring it to rest. A boy running in a playground can be stopped by dragging him in the backward direction. That means force is a physical quantity which causes a motion in a body or which opposes the motion of a body or which changes the direction of motion of a body. These are the effects of force. So the next is balanced and unbalanced forces. Balanced forces if two forces act on a body in opposite direction. If both the forces are equal, then the resultant force acting on the body is zero. Such forces are called balanced force. If F1 is equal to 40 Newton, F2 is equal to 40 Newton. So these forces are equal. So F1 is equal to F2. These forces are balanced. Unbalanced forces, if two forces act on a body in opposite direction and if one force is greater than other, then the resultant force is not equal to 0. If F1 is equal to 40 Newton, F2 is equal to 30 Newton, it means F1 is greater than F2. So these forces are balanced forces. So your next is the Newton's law of motion. So we have a three Newton's laws of motion. This is the first law of motion. An object remains in a state of rest or in a uniform motion in a straight line unless compelled to change that state by an applied force. Every body continuous in its state of rest or every body continuous in its state of uniform motion in a straight line unless compelled by net external force to change that state. For example, when we push a ball on the floor, it comes to rest automatically after some time. But the ball down does not come to rest by itself. It comes to rest due to the air resistance and the force of friction between floor and the ball. If we are able to eliminate these two forces, then the ball will continue to move forever in a straight line. Hence, first law of motion can also be termed as law of inertia. Inertia. Inertia is an inherent property of all the objects. Inertia of a body is directly proportional to its mass. Thus, mass of a body measures its inertia. So, inertia, it is the property of a body of which it opposes any change in its state of motion, that is state of rest or a state of uniform motion. That is the inertia of the body. So these are the examples of inertia. So inertia states that a body has the inability to change its state of rest or uniform motion, a motion with constant velocity or direction of motion by itself. So, mass of a body is a measure of inertia. Consider two stationary objects. One is heavier than the other. Now, if we apply the same force on these objects, then it is observed that it is difficult to move the heavier object than that of the lighter one. It means that the heavier object resists or opposes more to change in a state of rest than the lighter object. Thus, more is the mass, more is the inertia. Hence, mass of a body is a measure of inertia. So, your next is that momentum of a body. It is the quantity of motion contained in a body is known as linear momentum of the body. Momentum of a body is the product of its mass and velocity. P is equal to mv. P is momentum, v is velocity, m is the mass. So the SI unit of the momentum is kilogram meter per second. If a body is at rest, its velocity is 0 and so its momentum is also 0. So the linear momentum of body is directly proportional to the velocity of the body. So the linear momentum of a body is the product of mass and velocity of the body. So these are the examples of momentum of a body. So your next sign is that is Newton's second law of motion. According to Newton's second law of motion, he states that the time rate of change of linear momentum of a body is directly proportional to the net applied force on the body, and this change in momentum takes place in the direction of the applied force. P is the linear momentum, F is the net force applied. So according to Newton's second law of motion, force is directly proportional to the rate of change of momentum. So P2 minus P1 is equal to mv minus u. Change in m is the mass and v minus u final velocity minus initial velocity divided by time. So, or the applied force F is directly proportional mv minus u divided by t. F is equal to k. K is the constant of proportionality, and v minus u divided by t is equal to acceleration. So F is equal to ma. So the SI unit of mass is kilogram and the acceleration is meter per second square. The unit of force is Newton or kilogram meter per second square. And your next is that is Newton's third law of motion. Newton's third law of motion, to every action there is an equal and opposite reaction. He stated that to every action there is an equal and opposite reaction and they act on two different bodies. It means action and reaction act on two different bodies interacting each other. Whenever two bodies interact with each other, they exert equal and opposite force on each other. What out of these two forces, one is an action and another is the reaction. When a body A exerts some force on another body B, then the body B also exerts some force on body A. For example, when a player kicks a football, the football moves forwards and the foot of the player moves backward. So this is the Newton's third law of motion. These are the examples of action and reaction. So the last is conservation of momentum. According to this law, the total linear momentum of an isolated system remains constant, or the total linear momentum of a system remains constant if the net external force acting on the system is 0. According to Newton's second law of motion, force is equal to the rate of change of linear momentum. If force is equal to 0, the change in momentum is equal to 0. That means P is equal to constant. P is the momentum of a body. This is the law of conservation of linear momentum. Thank you.